Hello everyone, welcome to my channel. This is Vijay S. studying BE in Sri Venkateswara College of Engineering in section DO, USN number 1BE 23CA 054. Subject name Chemistry for CSE stream. Subject code BCHES 202. Explanation about memory devices. Here in this video, I am going to explain detailedly about memory devices, its classification and types with examples. Come, let us go inside the video. Introduction. In this presentation, we will explore the memory devices. We will dive into the functions and importance of these memory types in computing and storage of data. There are two types of memory devices, internal memory, secondary memory. Now I'm going to detailedly explain about these two types. Internal memory. Internal memory, also known as primary or RAM, is the temporary that holds data and instructions currently induced by the CPU. It is essential for real-time processing and multitasking. Example, RAM, cache memory, etc. Internal memory is also called as volatile memory and it is directly accessed by the computer. Secondary memory is also known as ROM or external memory. It is a permanent storage that holds data and instructions currently in use by CPU. And it is a volatile memory and it is not being directly accessed by the computer. Example, hard disk drivers, optical disk, CD, DVD. Next, I'm going to explain about history of organic memory devices. History of organic or polymeric memory devices. During 1968 to 70, bistable electrical conductivity and resistivity phenomenon was observed in polydinyl benzene and polystyrene polymer materials. But the performance for these memory devices was not that satisfactory for practical applications. In 1980s, two stable for electric polarization sats was discovered in polymers, but they required very high operating voltage of 30 volts. In 1995, ferroelectric polymer films as thin as 1 nanometer were fabricated, which requires 1 volt to switch between two states. In 2001, an organic field effect transistors memory devices was demonstrated using a TF1 oligomer as the conductor and a ferroelectric organic polymer as gate insulator. In 2000, a warm type memory device was developed consisting of a thin film PNN silicon diode. In 2004, ultra-thin film organic materials were discovered with multi-level conductivity states. The International Technology Roadmap for Semiconductors has identified polymer memory as an emerging memory technology since the year 2005. Now, we are going to discuss about the classification of electronic memory devices. There are four classification or types. First one, transistor type electronic memory. Second, capacitor type electronic memory. Resistor type electronic memory. And the last, charge transfer effects electronic memory. Now let us discuss about this clearly. First one, transistor type electronic memory. These types of devices contains a five electronic circuit, including a complementary metal oxide like semiconductor, transistor, and a capacitor. In this electronic circuit, 0 and 1 corresponds to the discharged and charged states of the capacitor. Example, DRAM, dynamic random access memory, SRAM, static random access memory, and some key materials are used in these devices such as silicon and metal oxide like silicon dioxide, and the metals like aluminum and copper etc. are used in this electronic memory. Next, capacitor type electronic memory. A capacitor type consists of two metal plates which are capable of storing an electric charge. It is used to store the data. It is like a battery that holds data based on energy. If the capacitor is charged, it holds the binary numeral 1 and holds 0 when the cell is discharged. Example: dynamic random access memory. Organic and polymeric ferroelectric materials are used in these types of memory devices. Resistor type electronic memory. This type of memory devices uses switchable resistive material to store data. Initially, the device is under high resistance state or off and logical value 0 state. When resistance changed or external apply field changes to low resistance state or on logical value 1. Example: resistive random access memory, and some key materials are used in these electric memories like TiO2, titanium oxide, HFO2, and metals like Ag, and dielectrics materials like silicon dioxide, and etc. Next, charge transfer effects electronic memory. This type of electronic device is based on the charge transfer effects of a charge transfer complex. A charge transfer complex consists of two parts. One, the electron donor, and the other one is an electron acceptor. Therefore, it is called as a donor-acceptor complex. The conductivity of CT complex is dependent on the ionic binding between the D and A components. Example: ferroelectric random access memory, FERAM. Conclusion. Coming to conclusion of this video. In conclusion, the diversity of electronic memory devices encompasses a rich tapestry of technologies, as each contributing to the advancement of modern computing and storage systems. As we navigate the complexities of memory landscapes, the quest for innovation and optimization continues to drive the evolution of electronic devices. Thank you friends for watching my video.